This write-up explores the effects of exploiting Log4j in a very well-known network appliance monitoring system called UniFi. This box will show you how to set up and install the necessary packages and tools to exploit UniFi by abusing the Log4j vulnerability and manipulating a post header called remember, giving you a reverse shell on the machine. You'll also change the administrator's password by altering the hash saved in the MongoDB instance that is running on the system, which will allow access to the administration panel and lead to the disclosure of the administrator's SSH password. Sorry to say, but there is a problem with the Windows machine. I can't foothold the UniFi network. I face the problem to get a reverse shell. I hope you all understand this problem. There is no GUI interface to import the OpenVPN configuration file, so that we have to do it with a command line utility tool. Firstly, you have to download the configuration file. Now open the terminal from here, type OpenVPN and import the OVPN file. Enumeration. The first step is to scan the target IP address with Nmap to check what ports are open. Here is a quick explanation of what each flag is and what it does. Where -sc performs a script scan using the default set of scripts. -sv version detection. The scan reveals port 8080 open running in HTTP proxy. The proxy appears to redirect requests to port 8443, which seems to be running an SSL web server. We take note that the HTTP title of the page on port 8443 is UniFi Network. Upon accessing the page using a browser, we are presented with the UniFi web portal login page and the version number is 6.4.54. If we ever come across a version number, it's always a great idea to research that particular version on Google. A quick Google search using the keywords UniFi 6.4.54 exploit reveals an article that discusses the in-depth exploitation of the CVE 2021-44228 vulnerability within this application. This Log4j vulnerability can be exploited by injecting operating system commands, OS command injection, which is a web security vulnerability that allows an attacker to execute arbitrary operating system commands on the server that is running the application and typically fully compromise the application and all its data. To determine if this is the case, we can use Foxy proxy after making a post request to the API/login endpoint to pass on the request to Burp Suite, which will intercept it as a middleman. The request can then be edited to inject commands. We provide a great module based on intercepting web requests. First, we attempt to log into the page with the credentials test as we are trying to validate or gain access. The login request will be captured by Burp Suite and we will be able to modify it. Before we modify the request, let's send this HTTPS packet to the repeater module of Burp Suite by pressing Ctrl+R. Exploitation. In this section, we have to input our payload into the remember parameter. Because the post data is being sent as a JSON object and because the payload contains brackets, in order to prevent it from being parsed as another JSON object, that we enclose it inside brackets so that it is parsed as a string instead. Now, we have to input the payload into the remember field so that we can identify an injection point if one exists. If the request causes the server to connect back to us, then we have verified that the application is vulnerable. Copy this code and paste it in the remember field. We have to modify it with the OpenVPN IP address. JNDI is the acronym for the Java Naming and Directory Interface API. By making calls to this API, applications locate resources and other program objects. A resource is a program object that provides connections to systems, such as database servers and messaging systems. LDAP is the acronym for Lightweight Directory Access Protocol, which is an open, vendor-neutral, industry-standard application protocol for accessing and maintaining distributed directory information services over the Internet or a network. The default port that LDAP runs on is port 389. After we hit send, the response pane will display the response from the request. The output shows us an error message stating that the payload is invalid, but despite the error message, the payload is actually being executed. Let's proceed to start the TCPDump on port 389, which will monitor the network traffic for LDAP connections. TCPDump is a data network packet analyzer computer program that runs under a command line interface. It allows the user to display TCP/IP and other packets being transmitted or received over a network to which the computer is attached. After the TCPDump has been started, click the Send button. The TCPDump output shows a connection being received on our machine. This proves that the application is indeed vulnerable since it is trying to connect back to us on the LDAP port 389. We will have to install OpenJDK and Maven on our system in order to build a payload that we can send to the server and will give us remote code execution on the vulnerable system. Firstly, we have to update the repository using sudo apt-get update. OpenJDK comes pre-installed with the Parrot security operating system. Find out the version by running the Java version command on the terminal. OpenJDK will also help us to run the Rogue-JNDI Java application, which starts a local LDAP server and allows us to receive connections back from the vulnerable server and execute malicious code. Now, visit the Rogue-JNDI GitHub page and clone this tool using git clone. Change the directory to Rogue-JNDI. Now run sudo maven package. Enough. I have forgotten to install Maven. I can install it using sudo apt-get install Maven. Once we have installed the required packages, proceed further with the Maven package. This will create a .jar file in the Rogue-JNDI/target directory called Rogue-JNDI 1.1.jar. Now we can construct our payload to pass into the Rogue-JNDI 1.1.jar Java application. To use the Rogue-JNDI server, we will have to construct and pass it a payload, which will be responsible for giving us a shell on the affected system. Now, copy this code to the terminal to create a base64 encoding the payload to prevent any encoding issues. Change the IP address with the OpenVPN IP address. Note, for this walkthrough, we will be using port 4444 to receive the shell. After the payload has been created, start the Rogue-JNDI application. Copy this code from article and paste it to the terminal. Now remove the base 64 code and paste this code. Now change the host name IP address. Now that the server is listening locally on port 1389, let's open another terminal and start a netcat listener to capture the reverse shell. Going back to our intercepted post request and click send. Once we receive the output from the Rogue server, a shell spawns on our netcat listener. We can upgrade the terminal shell. From here, we can navigate to Home, Michael, and read the user flag. Privilege escalation. The article states we can get access to the administrator panel of the UniFi application and possibly extract SSH secrets used between the appliances. First, let's check if MongoDB is running on the target system, which might make it possible for us to extract credentials in order to log in into the administrative panel. We can see MongoDB is running on the target system on port 27117. Let's interact with the MongoDB service by making use of the Mongo command line utility and attempting to extract the administrator password. Now, copy this command and paste it to reverse shell. The output reveals a user called administrator. Their password hash is located in the xshadow variable, but in this instance, it cannot be cracked with any password cracking utilities. Instead, we can change the xshadow password hash with our very own created hash in order to replace the administrator's password and authenticate to the administrative panel. To do this, we can use the makePassword command line utility. Once we've generated the SHA-512 hash, let's proceed to replace the existing hash with the one we created. Open a text editor and modify this command. Now copy this command and paste it to the reverse shell. Let's now visit the website and log in as administrators. It is very important to note that the username is case sensitive. The authentication process was successful and we now have administrative access to the UniFi application. UniFi offers a setting for SSH authentication, which is a functionality that allows you to administer other access points over SSH from a console or terminal. Navigate to Settings and click on Site. Scroll down to find the SSH authentication setting. SSH authentication with a root password has been enabled. The page shows the root password in plain text. Let's attempt to authenticate to the system as root over SSH. The connection is successful and the root flag can be found in root. Congratulations, you have finished the UniFi box. Paste both flags to hack the box. Before that, you have to solve all these problems. If you have any doubts or queries on my video, then write me a comment in my comment section.